All right, today I want to show how I have made gyro turn block, my block, that a couple of my teams have been working on trying to figure out. And this is one that is pretty general purpose, I think, and lets you turn left, right with kind of a top speed of your choice and does a nice coasting slowly to the end for accuracy. So let me just demonstrate and go down and just run the configuration I have here, which is turn 90 degrees to the right. So this right here is the sharpness of the turn, which can be anywhere from -100 to +100. The top speed is set to 50, and here's what it looks like. And if I want to turn to the left, I don't do -90, I do -100 for the speed, or the sharpness rather. And it goes there. So it's actually probably a little bit better to do, at least for demonstrating and maybe for use in a match or something, a top speed of maybe 20, maybe 30 or something like that. So if I want to go 180-degree turn to the left at a sharpness of 100, I would go like this, and you can see this. Okay, and then finally, this can be any value from -100 to +100. So if I do a 50-degree, or not 50-degree, but a 50 sharpness value, I don't really know exactly what to call it, but I call it sharpness. It'll look something like this. So it'll be a one-wheeled turn. Until the gyro sensor reaches 180. Okay, so there's a lot going on in the program behind this, and I'll open that up to show. So here's what it looks like. It looks like a bunch of wires. I didn't use any variables here. I kind of like to use wires just because it keeps the number of blocks smaller, but it is a lot of wires to follow. So I'll walk through how this works. So if you noticed, back in this tester program, there are 3 inputs. There's one which is how many degrees would you like the robot to spin around? And that's always going to be a positive number. So from 0 to whatever, 180, 360, whatever. 90 degree for a right hand or a left hand right angle turn. Then there's this top speed parameter, which is, I'll go back to the my block here. There's a top speed parameter, which is wired in a couple of different places. And then finally, there's the sharpness parameter. So whether you want a gradual left or right turn, you want a very sharp spin around the center point between the wheels turn, or something in between. Okay, so how does this work? First of all, you need to reset the gyro sensor, right? So that's necessary. Otherwise, it will have whatever random value, like you can see here, it's now reading 214 degrees negative from all the various, and it looks like it might have a little bit of drift on it. Yep, it's drifting a little bit. I don't have to worry about that too much in this block. But this just resets it to 0. That's all it does. Reset the, it's got a couple of modes here to select, but resetting it to 0 means we have a place to start from in this turn. Okay, I'm trying to decide what the best place is to look at here for the real meat of what it's doing. Notice there's only one motor block in this entire program, and it's right here. So something's going to feed in the steering value, which is actually what I call the sharpness. It comes directly out of the sharpness parameter and just goes right in there and nowhere else. Okay, so that's the sharpness of the turn it's going to make, and then something is going to be calculated to compute the power. So that's going to be starting out at some semi-high value and then dropping down to a low value until it's completed the turn. Okay, if we look back here, this is the other sort of meat of the program. This is doing a calculation based on A and B, which I'll explain in a second, and computing something that eventually is going to compute through this and turn into that speed. Okay, so that's kind of an overview, but let's look at let's go from the beginning here and look at how it works. First of all, I use this block right here just to calculate the opposite of whatever is coming in as A, and that's the top speed. So I now have the top speed. Let's say we put in 20 when we were calling it. Top speed is 20, and this will output negative 20, right? So we'll store that away in this wire, and it'll just connect up to one place over here, which I'll explain in a minute. Next, we have this absolute value block, which will take the number of degrees that they've asked to turn and take the absolute value of it. And that will, so if it was 90, it remains 90. If it was negative 90, it will turn in, oh, you know what? I should revise this program. But so actually this block is not going to do anything anymore because, as I mentioned in the beginning, you always want to put in a positive number. I was experimenting with putting in negative 90 for a left-hand turn and positive 90 for a right-hand turn. But the way I ended up here is you put in 90 degrees for either left or right, and you put in the sharpness from negative 100 to positive 100 for going left versus right. Okay, so at the end, I'll work through removing this, I guess, and just show how I do that. But if you notice here, where's this heading out? Oh, yeah. Maybe this is, yeah, this is actually correct. I guess I don't need to change anything. Anyway, so it takes the absolute value of the number of degrees that you want to turn, and it connects it to this wire, which goes all the way, way over here to something that's going to control when we stop. Okay? Okay, so now we get into this loop. And the loop is going to be determined by something. There's a logic block right here that tells us when it shuts off. I'll get to that in a minute. But basically, it's going to measure the number of degrees that we've moved from 0, right? Because we reset the thing right there. So measure the number of degrees that we've moved so far in this my block and spit that out a couple of different places. So this wire connects first to just the very next block, to B. So B here is going to be the number of degrees we've moved. And as we said earlier, A is going to be the number of degrees we want to move. Okay, so A is going to stay the same in here, but B is going to be always changing. And if you think about what this does, this idea actually is not my idea originally. I got this from a video that I'll put in the description to take A minus B here, so the number of degrees you want to move minus the number of degrees you have already moved. And that should be basically your power. Now I added a couple of things here. I added 5 to it, and I can explain that a little bit better in a graph. But the basic idea is you don't want it to reach 0 right when you're done moving, because if you get almost done moving and your power is almost 0, it's not going to move anymore, and it may not ever finish, and the block may just sit there forever, not quite finishing. So what I do is I just increase that a little bit. So I add 5 to it. So whatever number of degrees, let's say you've moved 83 out of 90 degrees that you want to move, that you want to turn. So it's going to be 90 minus 83 is 7. And then the power, and then add 5 to that, so 12. And so I want to keep that as a nice positive number when I still want to be moving. So that's why I add 5 to there. I'll skip over the why do I multiply it by 0.6, but just that the basic idea is I want to just make it a little bit slower of a stop at the end. Okay, so anyways, the result of that computation comes out here, and that becomes essentially the power that I want the robot to be turning with. Now, why do I have this trim block? I can explain this trim block. It's another my block that I'm using inside this my block. But basically all it does is I take some number, the output of power here, and I want to limit it to be between a low and a high value. Okay, so in this case, if you don't use a trim block right here, what's going to happen is, let's say you tell it to turn 180 degrees to the left or something like that. Originally, this is going to be 180 minus 0 plus 5, so 185, and then this multiplier on it. But it's still going to be like way up near 100, so it's going to start out moving super fast with its motors at its highest possible value, which is too high. We decided that we didn't like how this block, without trimming it down, we didn't like how it started out at power 100, which was really jerky, and we weren't sure if the sort of sudden torque on the gyro sensor would cause it to get a little bit out of calibration or something like that. So the idea here is we're going to trim it to be, remember how this top speed is sort of max power? It's going to, if we put in like a 20, this is going to trim it from negative 20 to positive 20, right? So this negative 20 came right out here and just directly into there and nowhere else. And this positive 20 comes right out of the parameter and up into the high. So there's a low and a high for this trim. And so whatever this number is, it's going to end up being somewhere between negative 20 and positive 20. Okay? So that result gets put out into the power for the motor. And as I was saying before, I was experimenting previously with like the power here being negative power versus positive power. The other way you can do it is negative steering direction versus positive steering direction. So I may be able to actually get away with a different trim here, like just limit it to positive numbers or something, but I probably won't change that because this is a little bit safer if I decide to change the program. Okay, so now we have a power here that's whatever power we want to be using, and it's between our max and min values for power. And we simply use it. So the steering is whatever angle they wanted to use for sharpness, and the power is whatever nice speed we have that will bring us smoothly to our target value for number of degrees we want to move. Okay, and then this is just hard-coded to be always ports C and D because that's what this robot is set up to do. But I guess, you know, set it to whatever your robot is set to do. I'm not sure if there's a, well, yeah, you can feed that in through a block. Okay, anyways. Okay, so that's all we want to do to get the robot turning correctly. Now we have to figure out how to stop when we're done. And that's what these last two red blocks are for. So this wire, it's a little hard to see because it goes through some other stuff, but it's coming out of the number of degrees that the gyro sensor has moved since the beginning of the program, right? So that'll go over here and take the absolute value of it. Why would we take the absolute value of it? Well, we may be turning left, we may be turning right, but at the end, we want to be, if they asked for us to turn, 90 degrees to the left, then this measurement is going to be negative 90, and we're going to be checking that against a positive 90. So we want to take this, take the absolute value of how many degrees we have turned, take the absolute value of, let's see, where does this come from? Absolute value here of the number of degrees we want to turn, and compare them. And if we've gone at least the number of degrees we want to turn, then we're done. Then we finish there. Okay, so there's a ton of wires here, hard to follow them all, but that is indeed how it works. Let me do one last little demo of the robot doing its turns. I'll go back to my tester program. So here it's set up to go turning to the left at like a one-wheeled turn. My daughter has placed a turkey here for me to move. One-wheeled turn to the left, turning 180 degrees, maximum speed of 20. Let's see how that works. Pretty good. Let's move this maximum speed up to 100. Should basically still work, but be a lot faster. But it might have some more sort of knocked off course because it's really jerky at the beginning. Let's see. Yeah. So the other thing to notice here is it went way too far, partly because it was moving fast, but also partly because I didn't put a brake the motor block in here. I probably should, so that you don't have to add that every time you use the gyro turn block. But I'm not sure if that would be good or not. Depends how it ends up being used, I guess. So that's another reason to keep this value at a nice low value. So let's say we have it at, I don't know, 40 or something. Do we still have such a problem? Let's see. Not so much. We got a little bit of back down at the end. Oh, I was going to explain why I have this 0.6 here. Okay, let me get out a whiteboard to explain this. All right, so here's my whiteboard. It's got like my team's stuff on it that I wanted to do for the next mission or the next meeting. All right, so here's the basic idea, right? We've got a plot of, let's say, degrees turned, and this is speed of the motors. Okay, now let's say we want to do something like 180 degrees turned, so we set that parameter to 180, and we have a top speed of, I don't know, 40. Okay, so if we think about this equation right here, a minus b plus 5, if we just did a minus b plus 5 and did not have this multiplier out here, then let's do just a minus b plus 5. That's going to be, if it's just a minus b actually, then that will be like 180. We'll start out at a speed of 180 and come down to a speed of 0 at the end, right? But since I put that limiter to 40, we're actually going to go speed of 40 until this point right here. Okay, so where is this? It's 40 degrees before there. So when it hits 140 degrees turned, it will start ramping its speed down. Okay, if I so that's the basic idea for, like, if we've got a limited speed here and then we want it to slow down at the end. Now what if I add 5 to that? Well, okay, if I go back, I draw my line like it was before. If I add 5 to that, it just raises this whole thing up. So at the end, it's still moving at a speed of 5, and it's going to get cut off right about here at 145, I guess. So now what if I multiply that whole thing by 0.6? Well, that's going to have the effect of taking this line and reducing its slope, right? So now I've got a line that still finishes at 180, but it started out, I'll draw this with thick ink, it started out at a smaller number, 0.6 times 180, right? So it's going to get to this point here and start decreasing a little bit sooner. And we found that that was necessary because you want to be able to trade off how long this decreasing part of the motor run is versus the flat part, right? So this is clearly not at all to scale, right? I should have put 40 is like way down here, right? So this is actually pretty long and then short at the end if you have 180 degrees. So that's what that 0.6 is there for. We haven't really tested what values are good there versus bad versus do we want to be able to customize that for each time we use it? We don't know yet. That's the explanation. All right, hope everybody enjoyed this, this demonstration, that there's something useful to take out of it. Use this block whenever you feel like you want to. Next time, I guess I didn't show the trim, how that block works. It's relatively simple in terms of its logic, but I could show that at another meeting, or another video. So thanks for watching. Hey, here's a little update to the program. I was having a little trouble with it when it turned left, and it turned out to be a problem in this part of the formula, the only formula I have in here actually. So my daughter helped me figure out that B here, which as we can see is the number of degrees that the gyro sensor has measured since the beginning of the MyBlock. B, where A is always going to be a positive number, no matter whether we're turning to the left or right. That's just by the design of the MyBlock. But B may be a negative or a positive number. So if we're comparing them, it's not going to work. So what I did is I added absolute value of B. Now we've got a positive number of degrees, no matter which, whether we're turning left or right. We add 5 to that and this 0.6 to make it a little bit more of a gentle stop than if I didn't have that multiplier. And everything works much better after that correction when we're turning left.